In this video, we'll be looking at how to use the method of the integration by parts to integrate products of the log function, where you have log times ax, and x, the x to the power of some function, like x to the power of 0, x to the power of 1, x to the power of 2, and so forth. So the first example here is the integral of the log of x dx. And it looks quite easy to begin with, but in fact there's a bit of a trick to it. And if you look at it here, this is equal to, you're kind of saying these are supposed to be products of log of x and x to the n. Where's x to the n? But if you look at this, this is equivalent to 1 times the log of x dx. And you can replace the 1 in that case with x to the power of 0. Because any number to the power of 0 is equal to 1. So now having done this, we now have it in the format where it's a product of x to the power of n and a log of x. So then what we have to do is, the rule is as follows: u dv is the product of u times v minus the integral of v du. That is the rule of the integration by parts. So what we need to get is, we need, first of all, how do we choose our u? Well, we go up to our table, which has the rules for choosing which term should be taken as u. And if our function contains a log of x, that should be the first one. That if the first priority, if it contains log of x, and in this case we have log of x and x to the n, but if there's a log of x, that should be set to u first of all. And if that's taken as u, then dv, which is this part here, is everything else in the original formula here. So if I take that out, that is the integral of x to the 0 dx. So basically, if I've taken this to be u, then everything else in here, including the integral, is taken as dv. So then, what we then say is we know this is u, the u dx is 1 over x. That implies that du is equal to dx over x, because we bring the dx up. On this side, we integrate both sides, so the integral of dv is v, and the integral of x to the power of 0, and that becomes x to the power of 1 divided by 1, so it's x. So we know what v is now, and we can say that v is equal to x. So now we have everything we need to plug into the formula. So the formula is the integral of u, so u is equal to the log of x, times dv is dv, and that is equal to u, which is the log of x. So this is my u, and the v goes in here, so v is x minus the integral. And basically I'm plugging these values into the formula up here. So it's the integral of v, so v is equal to x, and times du, and du is equal to, we have it over here, dx over x. So you can see straight away looking at this, that x will cancel with that x. And if I just swap this around so it's a bit neater, the x is out the front, that is equal to x times the log of x minus the integral of dx. And the integral of dx is equal to x. So we have x times the log of x minus x, and then I can just take out the common factor there is the x, so that is x multiplied by the log of x minus 1, plus of course our constant integration. So that is the first one, the integral of the log of x. And it's actually probably trickier than the ones we're going to do next, because you're kind of saying, when you look at it first, where is the x term? But basically, think about it, you can say there's 1 in front of that, you can replace the 1 with x to the power of 0. Okay, so move on to the next one. In this example, I'm going to integrate the product of x multiplied by the log of x, and we're going to integrate that product. If we look at it as before, we have our formula up here, which is the integration by parts. So this is the formula we're going to use. And you can see I've done a bit of color coding here to identify the parameters we need to work out. So to do this, we need to decide on what's u and what's dv. And then we have to basically work out u, v, and du from our initial choice. So the first question when you're doing integration by part is what are you going to choose for u? So you come down to your rules. The rules are here. Rules for choosing which term should be taken as u. If one of the factors is a log function, this must be taken as u. So straight away we're told u is equal to the log of x. Then what you can do is that automatically means that dv is what's left behind. What's left behind is the integral of x dx. So if you take out the log of x out of this term, you're left with the integral of x dx. The next thing you have to do is differentiate this. So du dx, the integral of log of x is 1 over x, and that implies that du, which is what we need for our formula up here, is equal to dx over x. On this side, we need to integrate v dv, and that will give us v, which we also need to get for a formula up above. We'll just do consistent color coding. So the integral of dv, which is equal to v, is the integral of x dx. So the x there becomes x squared divided by 2, and that is the v that we need. So if we take our formula, u dv is equal to, and the first thing I put in is the u, so that is the u here, sorry, that's the color code, is the log of x, that's my u, then my v is x squared over 2 minus the integral of v again, so that's x squared over 2 times du, and du we have over here is dx over x. So if I just go down, I've used a bit of color coding there just so we can differentiate everything. So if I rearrange this, that we have the x squared over 2 at the front times the log of x minus a half times, so I take out the 2 over here, the integral, and of course what happens here is we have an x underneath, x squared above, so we're left with an x up here, times x dx. And then we can go ahead and integrate that. So that's x squared over 2 times the log of x minus a half times, if I integrate x dx, it's x squared over 2. That's a constant of integration. And you can see we have x squared over 2 is common to each of these. So it's x squared over 2 times the log of x minus a half. That's a constant of integration. And you may not want to write it like that. You may want to write everything over 2 there. How do you do that? That would be done by writing it like this. X squared over 2 times the log of x minus 1 over 2. So this is basically 2 log of x over 2. And that's how you can write them over a common multiple, and then bring this 2 outside. So it's x squared over 4 times 2 times the log of x minus 1. You don't have to do that. The only purpose of that is you might write this half up here. So to get rid of the half, you can write log of x as 2 times the log of x over 2. Then you can put both of these over 2, so it's 2 times the log of x minus 1 over 2. And then you can take that 2 outside and multiply it by the other 2, give you 4. So it's x squared over 4 times 2 log of x minus 1. That's that one done. In this example, we're integrating the product of x squared and the log of x. So look at this example here. The first thing we need to do is we're going to apply our rule, integration by parts. So we need to work out u, dv, v, and du. So we need the parts to plug into this formula. So the first job you need to do is decide which term is going to be equal to u. We come up to our first rule up here. The first rule says if one of the factors is a log function, it must be taken as u. So I'll say u is equal to the log of x. dv is everything that's left, so that's x squared dx. So it's the integral of x squared dx. I need to differentiate u, so I get du dx is 1 over x, and I need du for my formula up here. So du is equal to dx over x. I also need to get v for the formula up here. This is used here and here. So to get v, I integrate dv. So I'm going to integrate both sides of this equation. So the integral of dv, which is equal to v, is equal to, the integral sign is out here anyway. So the integral of dv is the integral of x squared, and that gives me x cubed over 3. So if I come along and plug that into the formula, x squared, I'll put this in black, times log of x times dx is equal to u, which is the log of x, times v, which is x cubed over 3. So let's just say that's equal to v here. It's equal to x cubed over 3. Minus the integral, it's v again, so it's x cubed over 3. I'm dividing that by du. Du is here. It's dx over x. So if I work that out, bring the x cubed to the front, just to tidy it up, minus the integral, and of course I have an x underneath here, which cancels these, so it becomes x squared. So I have x squared, and I can bring the third outside, dx. So I'm bringing this 1/3 outside. So that gives me x cubed over 3 plus the constant integration. Oh, I don't have that yet. I have to integrate it. So it's x cubed times the log of x minus a third times, and this is the integral of that is x cubed over 3 plus my constant integration. Now, if you see here, I have x cubed over 3 in both terms, so if I take it out, that gives me the log of x minus a third plus my constant integration. And if you remember, the last one was x squared over 2 times the log of x minus a half. So in a case like that, you can see the pattern is repeating here. But what I can do is do what I did the last time, which is say that's equal to x cubed over 3. I can multiply above and below here by 3. So it's 3 times the log of x over 3 minus a third plus the constant integration. Then I can say that's x cubed, and I can say 3 divided by 3 times the log of x minus 1 over 3. That's basically, these now share the same denominator, so you can make them one statement. And the last thing is you take 3 here out, so 3 times 3 gives me 9 times 3 times the log of x minus 1 plus the constant integration. So that last step there just gets rid of the fraction at the end here. This is the last question which we'll do of this type. And basically we have a product of x cubed times the log of x. We need to use this equation up here, integration by parts. So we need to determine what's u, what's v, what's times du. So first of all, we follow a rule once again. Follow this rule. It says if one of the factors is a log function, it must be taken as u. So u is equal to the log of x. That means the integral of dv is everything else. So it's x cubed, integral of x cubed dx. Everything else up here in the original statement. We integrate this side over here, so du dx is equal to 1 over x. So that implies du, which we need for our formula up above, up here, is equal to dx over x. We also need v up here, here, and here. So to get v, we integrate dv, which is equal to v, and we get that by integrating the term here, which is x cubed dx. So that gives us x to the 4 over 4. So now we have the values we need to plug into our formula. So we have u dv is equal to u, once again, is the log of x, times v, which is now x to the 4 over 4, minus the integral to x to the 4 over 4, which is v again, times du. Du is dx over x. So if we tidy it up, we can bring the x to the 4, x to the power 4 divided by 4 to the front, multiply by the log of x, minus, I can take the quarter out here, and just to be aware we have an x underneath here that cancels with v, so we have x cubed. So it's the integral of x cubed dx. This is equal to x to the 4 over 4 log of x, minus a quarter times the integral of x to the power 3 is x to the 4 over 4, plus our constant integration. So scroll down and continue on here. That gives us x to the 4 over 4 is common to both of them, times the log of x minus the quarter, plus a constant integration. As before, we can try and tidy this up by multiplying the log of x above and below by 4. So now they have a common denominator. Then we can put this over, so it's x to the power 4 over 4 times 4 times the log of x minus 1 over 4 plus the constant integration. Now we can finish off by taking that 4 out underneath. So 4 times 4 gives me 16 times 4 times the log of x minus 1 plus a constant integration. So we've done the 3 examples there, but you can see the pattern, so it repeats. And if you look at that there from the previous ones, you can see this kind of a repeated pattern here. By x to the power of n times the log of x dx is equal to x to the power of n plus 1 divided by n plus 1 multiplied by the log of x minus 1 over n. So when we had log squared, we ended up having x cubed over 3 times the log of x minus 1/3. So you can see there's a pattern that repeats in that case. That is the end of this example.